dapat tayo ay 51 dito. Nandito na ba si Mr. De Villa? Let's start chapter 1, module 2. Ano po oras ng klase natin ng face-to-face?
10 to 1 po, ma'am.
Ng
Friday po.
Friday. Okay. So, ayan. Alam ko naman hindi natin ito matatapos. Medyo mahaba kasi ito. So, in case hindi natin matapos today, ay continuation na lang natin sa Friday ng face-to-face. Okay, so again, ang face-to-face po natin ay sa machines laboratory. Okay, so yan, nakikita na po ba yan? Module 2. Okay. So, ang topic natin today is magnetism and electromagnetism. Okay. So, pasabi na lang sa akin kung nalipat ang slide or kung nagpuputol-putol lang aking salita. At medyo may kabigasan kasi yung internet dito. Okay. So, magnets play a big part in our everyday lives, and most of the time we only think of those little things that hold our papers on the refrigerator or of what makes a compass work. But magnetism helps us in many other ways that we usually never see or notice. So, let's say we have our credit cards, computer hard drives, motors, generators, and speakers all use magnetism. Okay, so the Earth is one giant magnet too, and if we use magnets in so many different ways or different areas of our lives, we should understand how they work and how we're able to use them in technology. So here we will understand how magnetism or magnets work. Okay, and ayan, before we go there, let's have a brief history about magnets. No. So the ancient Greeks and Chinese discovered that certain rare stones called lodestone. Yes, meron po ba?
Ma'am, hindi ata po nalipat ang PPT.
Hindi. Yun na nga bang sinasabi ko. Ang hina kasi ng internet. Nakashare na yung entire screen ko eh. Hindi pa rin pala nalipat. Yan, sasabihin nyo agad ha. Kasi minsan ay hindi sinasabi sa akin ay nakatatlong slide na ako. So, ayan. Oo, nakatatlong slide na ako. Tsaka po sinabi na hindi nalipat. Kadami ko nang nasabi. Okay, so brief history. The ancient Greeks and Chinese discovered that certain rare stones called lodestones were naturally magnetized. So these stones could attract small pieces of iron in a seemingly magical way and were found to always point in the same direction when allowed to swing freely, suspended by a piece of string or floating on water. Early navigators used these magnets as rudimentary compasses to help them determine their direction while at sea. So, ang pinakaunang magnet na na-discover ay tinatawag na lodestones. Okay, so tatandaan yun or i-take note ninyo, baka mapasama sa exam. Okay, so the word magnet comes from Magnesia, which is a district in Thessaly, Greece, where it is believed that the first lodestone was mined. Okay, so galing pala siya sa Greece. So over the years, magnets have evolved into the high-strength materials we have today, and it was discovered that by creating alloys of various materials, one could create similar effect to those found in natural lodestone rocks and increase the level of magnetism. So after ng lodestones, na tawag dito, na-discover nila na meron pa palang ibang way para magkaroon or makagawa ng magnet. Ano? Which is alloys. Ano? Creating alloys of various materials na mas mataas pa yung magnetism kesa sa lodestone. Okay? So, however, it was not until 18th century that the first man-made magnets were created. Okay? So, tatandaan nyo ha. I-note ninyo, 18th century, first man-made magnets were created. Then, progress in creating stronger magnetic alloys was very slow until the 1920s when alnico magnet materials were formulated. Okay? So, 1920s, merong alnico magnet na formulate. Ano? Then, after nun, ferrite magnets were developed in 1950s and rare earth metals or magnets in the 1970s. So, please remember all those years. Yan, yung mga years na nandyan. And kung ano yung na-discover nila. Okay, so since then, the science of magnetism has grown exponentially, and extremely powerful magnetic materials have made miniature and powerful devices possible. Okay, so that's the brief history of magnets. Okay, so magnets can be made by placing a magnetic material such as iron or steel in a strong magnetic field. Permanent, temporary, and electromagnets can be produced in this manner. Then, the atoms forming material that can be easily magnetized, such as iron, steel, nickel, and cobalt, are arranged in small units called domains. So, meron palang different types of magnets. Ano, we have the permanent, temporary, and electromagnet. So, before we proceed there to the different types of magnets, I will play a video about magnets and magnetism first. Ano? So please understand this video and later I will ask you about the video. Ay, wait. Ayan. Nakikita. Can you see the video now?
10% lang na.
Yes po.
Okay.
10% sasabihin natin.
If you've ever played with magnets, you'll probably notice that when like poles of the magnets are facing each other, so two norths or two souths, the magnets will repel, but poles of the magnets are facing each other, so two norths or two souths, the magnets will repel, but hold two unlike poles together, they will attract. Magic. Well, not really. And here's why. All magnets have something called a magnetic field. Magnetic fields are invisible and surround the magnet, causing a magnetic force. This is what causes magnet materials and magnets to either attract or repel. Magnetic fields always follow a few basic rules. Even though magnetic field lines all have the same strength, the strength of the magnetic field is greater the nearer to the magnet. Can you guess why this is? It's because the field lines are more concentrated, increasing the overall strength of the magnetic field. If you think of a magnet, you don't see lines coming out of the poles. Magnetic field lines are invisible, but there are two things we can do to show the field lines. Iron filings can show us the shape of the magnetic field, which we show as a simplified diagram like this. So iron filings show us the pattern, but they don't show us the direction, which is where compasses become useful. So how can compasses show us the direction? Place some small compasses around a magnet. The arrows of the compass will move so that they are pointing towards the direction of the magnetic field. Then, using a pencil, draw a dot where each arrow points and then connect the dots. The compasses will show the direction of the field lines going from the North Pole to the South Pole. Simple. We now know the direction of the magnetic fields. We will look at compasses and the Earth in another video. There are two different types of magnets, permanent and induced. Permanent magnets are always magnetic, meaning that their magnetism can't be turned off, whereas induced magnets aren't always magnets. They are unmagnetized most of the time, but when placed inside another magnet's magnetic field, it acts like a magnet and attracts. Magnetic materials like iron and steel can be turned into magnets. If you place an iron paperclip close to a permanent magnet, but without touching, the paperclip will become an induced magnet, with the end nearest the magnet having the opposite polarity of that of the magnet. Because the paperclip is now an induced magnet, we can add another paperclip to it, and another paperclip. This is of course a temporary process. Remove the nail of the magnet and the nail will lose its magnetism. So in this video, you learned about the north and south poles in magnets, attraction and repulsion of magnets, magnetic fields, and the difference between permanent and induced magnets.
Okay, so do you understand what the video says? Okay, so please copy this part. Yan. Okay, please copy this part. The characteristics of magnetic fields.
Dropping naman, gawin nyo na pong i-drop. Basic electrical engineering na po ang ating business. So, napaka-basic lang po na ating mga problems. Ito na may complex, medyo may pagka-complex yung ating topic. So, I'll make sure na matutunan nyo na.
Hello, okay na?
If hindi nyo mag-gets, pwede kayo magtanong, pwede kayo mag-raise ng mamay sa ating legal class meeting para mapaulit natin ang ating mga hindi.
Hello po.
Ayos na po, ma'am.
Okay na.
Even though magnetic
Okay, so let's proceed again to our PowerPoint.
Due to unforeseen circumstances, personal issues, na para kailangan talaga i-drop yung subject.
Okay, so dito tayo sa different types of magnet.
Kapag nakapag-submit kayo ng drafting form sa registrar's office,
Okay, so sabi dun sa video, we have two types of magnets, which is permanent and induced. So under the induced, we have the temporary magnets and electromagnet. Okay, so permanent magnet is an object made from a material that is magnetized and creates its own persistent magnetic field. A permanent magnet is one that retains its magnetic properties for a long period of time. Say for example, we have here iron, nickel, cobalt, and some rare earth alloys. So an everyday example is a refrigerator magnet used to hold notes on a refrigerator door. So when we say permanent magnet, it doesn't, the magnetic or the magnetism of that object cannot be turned off or turned on. Okay? So it's always magnetized. That is a permanent magnet. Then we have induced magnets, which is a temporary and electromagnet. When we say temporary magnets, it is made out of soft metals that retain their magnetism only when they are near a permanent magnetic field or an electric current or electrical current. In the presence of a magnetic field, they become magnetized. Okay? Just like the paper clip kanina, right? When the paper clip moved near to the magnet, there's a magnetic field, so that the paper clip will be magnetized, and when you put another paper clip and another one and so on, it will become magnetized also. But then, pag tinanggal mo siya or you removed it near the magnet, it will be demagnetized na. Okay, that's why it's only temporary. When it's near only sa magnet or sa magnetic field. Okay? Then we have the electromagnet. An electromagnet is a type of magnet in which the magnetic field is produced by an electric current. Electromagnets usually consist of wire wound into a coil, and a current through the wire creates a magnetic field, which is concentrated in the hole in the center of the coil. Okay, so the word itself, electro, then magnet, meaning pinagsama na siya, meron na current or electric current na ah, tawag dito, naka-partner. Okay? So, ito naman, this is an example of wire wound into a coil. So, ito yung wire natin. This is the wire. Then, the coil is this black one. Wait a minute.
Na-discuss na rin natin last week yung ating heating effect.
Okay, so
Tapos which ay
again, this is an example of a wire wound into a coil. This is the wire which is wounded into a coil. This is the coil, the black one. Okay, so we have here the positive and negative ends of the wire. Then if you put there electrical current, it will become or it will produce a magnetic field. Okay, and then at the center of the coil, the magnetism is concentrated. Ibig sabihin, doon sa loob nitong coil na to, doon malakas ang magnetism. Doon siya concentrated inside the hole or at the center of the coil. Okay, but then, if you remove the electrical current, nothing will flow. No current will flow. Ibig sabihin, walang magnetic field. That's why it's also like a temporary magnet. Induced magnet siya. When there's an electrical current, there's a magnetic field, but then if there's no electrical current, no magnetic field. Okay? That's why it's called induced magnet. Again, we have permanent magnet and induced magnet. Under the induced magnet, we have temporary magnets and electromagnet. Okay? Okay. Lumipat ba? Lumipat ba ang slide?
Opo, ma'am.
Okay. So we have here now the classification of matter according to the magnetic property. So it depends. So you will know what material it is based on the relative permeability. Okay? Relative permeability or mu R. Okay, so we have here ferromagnetic. Okay, so it is a material or are materials that can be magnetized, which are also the ones that are strongly attracted to a magnet. Okay, so this includes iron, nickel, cobalt, some alloys of rare earth metals, and some naturally occurring minerals such as lodestone. So, sa madaling salita, ito yung bakal. Yung mga madaling ma-magnetize. Okay? Ang tawag doon is ferromagnetic material. Okay? So, doon siya classified. Okay, so to know what kind of material, first is you have to know what is the relative permeability. So when your materials relative permeability is very very high or more than one, let's say what hundreds or thousands. Okay, let's say your relative permeability is 3,000. Okay, 3,000. Yun yung given. So your material is ferromagnetic. Okay, when it's very high, the relative permeability is very high, it is a ferromagnetic material. But then we have also paramagnetic. So substances such as uranium, platinum, aluminum, sodium, magnesium, chromium, and oxygen, are weakly attracted to either pole of a magnet. This attraction is hundreds of thousands of times weaker than the ferromagnetic material. So it can only be detected by using sensitive instruments or using extremely strong magnets. So to know what material or substance, so first you have to know what is the relative permeability. So the relative permeability of a paramagnetic substances is greater than 1. Okay, let's say 2 digits. Let's say 10, 20, 50, or 5, like that. That is a paramagnetic substance. Okay, that is that's the difference between ferromagnetic and paramagnetic. Okay. Then we have also diamagnetic. So it means repelled by both poles. So compared to paramagnetic and ferromagnetic substances, diamagnetic substances such as bismuth, mercury, silver, zinc, carbon, copper, water, and plastic are even more weakly repelled by a magnet. That means the relative permeability of a diamagnetic material is less than 1. Let's say negative 10, negative 20, and so on. Okay? So when the relative permeability of a material is negative or less than 1, it is a diamagnetic. Ano? It falls in the classification of diamagnetic material. Then, when it is greater than 1, let's say 10, 20, 100, it is a paramagnetic. Okay? Then, if it is thousands, like 1,000, 2,000, 3,000, and so on, it is a ferromagnetic material. Okay, so that is a classification of matter according to the magnetic property. Okay, next is magnetic field. Okay, so magnetic field is the region surrounding a magnet where the magnetic force can be detected. So as you can see sa video kanina, okay, ang ating magnet ay nagpo-produce ng invisible field, which is called the magnetic field. It is an invisible field produced by the magnet around it. So alin yun? This is the magnetic field. Yung kabuuan, yung buong ito, yung mga lines na yan, yung buong ito ay magnetic field. Okay, so any ferromagnetic material will experience a force of attraction in a magnet, right? Because they are easily attracted to magnets, the ferromagnetic materials. So we cannot see this field, but it exists. Okay, so this field is produced by a magnet and is called the magnetic field. Then we also have the magnetic lines of force, which is the imaginary lines that indicate the path taken by an independent end pole in going from north to south pole of the magnet. Okay, so magnetic lines have only one direction. It's only from North Pole to South Pole. Okay? North Pole to South Pole only. Okay, so ano ba? Wait lang. Iniipon ko lang yung English ko. Okay, so dito muna tayo sa properties. No? So properties of lines of force. They do not touch each other, they do not cross each other, and they are elliptical, closed curves. So yan yung properties ng ating lines or magnetic lines. Okay? So hindi sila overlapping. Lagi silang magkahiwalay. They do not touch each other. Okay? Then, there are ways to see the invisible magnetic lines. Okay, so what are those? Okay, so first is using iron filings. Okay? So that will be your first laboratory experiment. Okay? So, please prepare na. Ano? Prepare iron filings and a magnet with north and south pole. Okay? So, using that, we can see the magnetic lines around the magnets, right? Then, it only shows us the magnetic lines, but not the direction. That's why we will use compass also. Okay, because the compass will show us what is the direction of the magnetic lines. Okay, which is from North Pole to South Pole. Okay? Napanood nyo naman yun kanina, di ba? Okay. Then, how is magnetic field created? So when current flows in a wire, a magnetic field is created around the wire. Okay, that is an electromagnet. So from this, it has been inferred that magnetic fields are produced by the motion of electrical charges. So parang uh, kinumpare nila. Ano, now, when there's a current flowing in a wire with a coil, there's a magnetic field created. That's why they assume na magnetic fields are produced by the motion of electrical charges. Okay, so a magnetic field of a bar magnet does result from the motion of negatively charged electrons in the magnet. Okay, so magnetic field lines are defined to have the direction in which a small compass point when placed at a location in a field or in the field. So the strength of the field is proportional to the closeness or density of the lines. What does it mean? Okay, this means that the strength of the magnetic field is greater closer to the magnet and decreases as we go farther from it. So paglapit sa magnet, paglakas ng magnetic field. Paglayo sa magnet, paghina ng magnetic field. Okay?
Sila pala yung nakapag-share ng first alam.
Next, we have the law of magnetic poles, which is like pole repel and like pole attract. You already know it. Siguro bata pa kayo. Alam nyo na ayan. Okay, so, pagka north to north or like pole, repel. Ano? Kahit anong pilit nyo na pagdikitin ang dalawang magnet na parehas ng pole, let's say north to north, hindi talaga siya magbibigay. Ano, like this. Ayan. Because the magnetic field lines are all outward. Like that. Ano, outward. And parang, kumbaga, nagsasalubong. Diba? Nagsasalubong yung flow ng magnetic lines. Okay? Then we have here north to south. Okay? So as you can see the arrow is like continuous. They only have one direction. Ano, from north to south pole. Okay, that's why unlike pole attract. Not like this one. Okay? Next. So, magsa-start na tayo sa mga formulas and kinemerons. Okay, so the phenomena of magnetism and electromagnetism are dependent upon a certain property of the medium called its permeability. So, permeability have ano tawag dito? It possesses two permeabilities. Ano? The absolute permeability and relative permeability. So, absolute permeability is mu O or mu sub O. Relative permeability is mu sub R. Hello, naririnig niyo pa ba ako? And lumipat pa rin ba yung ating slide?
Yes po, ma'am.
Yes po.
Okay. So, ayan. So, for measuring the relative permeability, a vacuum or free space is used as reference medium. It is allotted an absolute permeability of mu O, which is 4 pi times 10 raised to negative 7 Henry per meter. So, ito po ay constant, ha? And the relative permeability of vacuum with reference to itself is unity. Okay. So, ayan. So, pag sinabi po na free space, nasan ng aking pen? Yan. Free space, pag po may sinabi sa problem na free space, you will use absolute permeability or constant 4 pi times 10 raised to negative 7 Henry per meter. Okay, and then the relative permeability is mu r, which is equals to 1. Okay, so, but you will use 4 pi times 10 raised to negative 7 Henry per meter if your, tawag dito, wait lang, nasa dulo ng dila ko. If you will base in MKS unit. MKS unit ang gagamitin mo, you will use 4 pi times 10 raised to 7 Henry per meter. But then, if you will use CGS units, like centimeter, gram, and seconds, you will use 1. Okay, but in MKS, ano ba si MKS? What is MKS? What is MKS? MKS unit is a physical system of measurement that uses the meter, kilogram, and seconds as the base. Okay, so that is MKS or SI unit. So, if you don't like to memorize this constant, which is 4 pi times 10 raised negative 7, you can find it in your calculator, which is constant 33. So, get your calculator, then press shift 7, 33, shift 7, then press 33, then equals, lalabas dyan, mu O, then equals. That is the absolute permeability, which is 4 pi times 10 raised to negative 7 Henry per meter. Okay, but that is for MKS or SI unit only. If you will use CGS, just use 1. Okay?
Kapag ako may English, ako may foreigner, sabi ko, okay, you understand me? If you don't, that's okay. That's okay. That's challenge in your life. You can overcome this one.
Okay. Then, for relative permeability, when the problem says vacuum, free space, or air gap, you will use 1. Okay? 1. Mapa MKS or CGS, you will use 1. Okay? And if there is no given mu r or relative permeability, matic or automatic, you will use 1. But if there's a given, let's say relative permeability is 3,100 or something like that, you will use it. Okay, but if there's no given, use 1. Okay, and if the problem says free space or vacuum or air gap, use 1. Okay, so take note, ha? Take note. Walang given, matic 1. Pag sinabing free space, vacuum, air gap, matic 1. Pero pag may binigay sa inyo na relative permeability, you will use it. Ano, hindi na 1. Meron ng value na binigay. Okay. So, if we take any medium other than vacuum, the absolute permeability is expressed relative to the permeability of free space, then, okay. So, di ba, meron tayong pinaka-tinatawag na permeability, which is mu. Si mu lang, mu. Parang ano lang, no? Parang may sipon lang, mu. Yan. So, etong si mu, yan po yung permeability. Then, to get the permeability, you will use mu O and mu R, which is absolute permeability times relative permeability. Permeability. Yan. Okay. So, iba po si mu kay mu O at kay mu R. Okay, so to get relative, to get permeability, you will use absolute permeability times relative permeability. Kapag ka lang naman hinahanap, pag hindi naman, hindi mo naman gagamitin. Okay, next we have the magnetic flux or magnetic lines of force. Okay, so what is the symbol for magnetic flux? We have phi. Ano, phi. Ganito yata spelling niya. Phi. So the entire group of magnetic field lines which flow outward from the north pole of the magnet, it is a number of magnetic lines of forces in a magnetic field. So alin yung magnetic flux na yan? Diba ito yung magnet? Just from north to south pole. Diba merong ganyang arrow? Yan. So, yan po yung ating magnetic flux. Okay? Magnetic flux is the number of magnetic lines of forces in a magnetic field. So, kung ilan yung lines na yan, yun po si magnetic flux. Okay. So, meron po ba kayong concern? Parang may nag-notice. Lumilipat ba?
Face-to-face ang ating video mo sa
Lumilipat ba yung ano? Okay. Sorry po. At for the sick pa rin ang person. Okay. So that is magnetic flux or phi. Magnetic flux have different units. Ano? For SI unit, CGS, and English unit. Okay? So we have the Weber. It is an SI unit of magnetic flux equal to 10 raised to 8 lines of Maxwell, and it is named after the German physicist Wilhelm Weber. Paano yung basahin? Wilhelm Weber. Kayo na po ang bahala, ha? Okay, next we have the Maxwell, which is a CGS unit of magnetic flux equal to 1 line of force. So, it is named after the Scottish physicist James Clerk Maxwell. Okay? So, ilagay natin sa table. Ay, nakalagay na pala. Okay. So, we have here the magnetic flux or phi. In MKS or SI unit, we have here Weber or WB. In CGS unit, we have Max or Maxwell. Then, in English, we have lines. Lines, okay? Excuse me po. Oh my God. Next. Okay, naintindihan ba yun? In MKS, or pag ang base ninyo is meters, kilogram, and seconds, you will use Weber. But if your base is centimeter, gram, and seconds, you will use Maxwell or Max. And then if it's English, you will use lines. Okay? Okay. Next, we have the magnetic flux density. So the magnetic flux per unit area of a section perpendicular to the direction of flux. That means the formula in getting the magnetic flux density is phi, or magnetic flux divided by area. To get the magnetic flux density, you will use magnetic flux divided by area. So if that's the formula in getting magnetic flux density, then what will be its unit? So the unit will be, first, lagyan muna natin yung unit ni area. Ano? Depende sa kanyang base. Okay? So the area in MKS or SI unit is square meter. In CGS, we have square centimeter. And in English, we have square inch. Okay. So if the formula of flux density is flux divided by area, then the unit will be equal to Weber per square meter, right? Ayan, which is equivalent to Tesla. Then, if you're gonna use CGS-based unit, you will have a unit of Maxwell per square centimeter, which is equivalent to Gauss. Gauss or GAUSS. Then in English, you will have lines per square inch. Wala na siyang equivalent. Okay? So, naintindihan? Okay, so please practice using MKS, CGS, and English units. Okay, yung mga tawag. Tatandaan niyo yung table na yan. Pwede nyo rin siyang isulat sa inyo. Index card. Okay, so we have conversions. Okay, so we have one line is equal to 1 Maxwell. Then we also have 1 Weber, which is equivalent to 1 times 10 raised to 8 Maxwell. And we have 1 Tesla, which is equivalent to 10 raised to 4 Gauss. Okay, tatandaan ang conversion na yan. Okay, tatandaan yan. Okay, so ito lang din yan ha, yung sinulat ko na yan. Yung mga units ni flux density. Then we also have conversions here, which is an important factor. Okay, so we have charge or Q, which is equivalent to 1.602 times 10 raised to negative 19 coulombs. Then we have 1 pound-foot is equivalent to 4.4484 Newton. Nice. Pag sinabing Newton, saan yun ginagamit? Then 1 kilogram foot is equivalent to 9.81 Newton. Then we have 1 Tesla into 10 raised to 4 Gauss, 1 Newton into 10 raised to 5 dynes. Okay, so coulomb ay pang charge. Pagka ang unit ay naka-pound foot, kilogram foot, Newton, at dynes, that is for force. Okay? Force po yan. Force. Kapag ka Newton, naka-SI unit yan or MKS. Kapag ka dynes, naka-CGS unit yan. At kapag ka pound-foot is naka-English unit yan. Okay? So, ayan. Naintindihan. Tatandaan nyo ha. Yung mga yan. Okay. Nagko-chorus na tayo, sir.
Last one.
So, the amount of attraction or repulsion. Okay, bura-bura. Again.
Gerald.
So, force on a charge is the amount of attraction or repulsion between charged objects. It can be put in a quantitative terms by the introduction of the electric force. Okay, so, to get the, or, tawag dito, si force daw pala ay pwedeng makuha in terms of numbers or numerical or quantitative. So, how? Okay. So, the simplest case to consider is the force between 2 points charges. Charges with a negligible size. So, kahit ano pa ang size ng charge or ng 2-point charge na yun, wala siyang bearing. Ano kasi negligible nga yung size dito. Wala naman sa force na formula yung size. No, hindi siya pinagbabasihan. So we have here QVB sine theta, which is in Newton. Ibig sabihin, itong formula na to gagamitin mo lang pagka MKS ang base unit mo. What does it mean? So si Q is the charge in terms of coulombs. Okay? So magagamit mo lang itong formula na to pagka ito yung mga units ng mga given. So for flux density, we have it in Tesla. Then si velocity is in meter per second. And then sine theta. And theta is the angle between the wire and the magnetic field. Okay? So pagka po hindi ganito ang tawag dito. May nagana ang aking pen. Wala ng tinta. So pagka hindi ganito ang unit ng given, kailangan niyo pong i-convert para magamit mo siya dito. Or mai-substitute mo sa formula na ito. Okay, again, if the given units is not like this, which is coulomb, Tesla, and meter per second, you have to convert it. Okay? You have to convert it. What if your flux density is in terms of cos? You have to convert it to Tesla first before putting it here. No. So you have to convert it first. So what is the conversion of Tesla to Gauss? 1 Tesla is equivalent to 10 raised to, ano ba? Hindi ko natandaan. 10 raised to 4 Gauss. Yan. You have to convert it. Okay? Next, electromagnetism. So it is a force. Ano daw? It is an a force. Ay nako. So it is a force on a current carrying conductor lying in a magnetic field. Okay? So a current consists of many small charged particles running through a wire. If immersed in a magnetic field, the particles will be experience a force and they can transmit this force to the wire through which they travel. So the force on a section of wire of length L carrying a current I through a magnetic field of beta. So from that, malalaman nyo agad na yung force or to get force, maaaring merong length, current, at magnetic field dyan na kasama. Ano sa formula. So, tingnan natin. Wow, meron nga. Charis. Okay, so meron nga. Ano? So, to get the force on a current carrying conductor lying in a magnetic field, we have to use these different formulas. So if your unit base is MKS, you will use this formula. If CGS, you will use this formula. And then if it is English, you will use this formula. Okay? So, paano ba malalamang MKS? Okay? So we have here F is equals to BIL sine theta. If your magnetic field or ano daw, flux density, sorry. If your flux density is in terms of Tesla, it is in MKS. If your length is in meter, MKS yan. Kaya nga meter, kilogram, at seconds. Okay? So you will use this formula. What if your flux density is in terms of Gauss? Gauss is in terms of CGS, right? And also, if your length is in centimeters, it is in CGS. So that you will use this formula. So we have F is equals BIL sine theta over 10, and your unit will be dynes. Ano? As I said kanina, dynes, Newton, and pound-foot is for force. Ano? So ito ay Newton. Okay? Then we have here English naman. If your flux density is in terms of lines, it is in English. And if the length is in inches or feet, then it is in English. You will use this formula, which is force is equals to BIL sine theta divided by 11.3 times 10 raised to 6. Then your unit will be pound foot. Then, kung mapapansin nyo, current is always in ampere. Kasi wala naman ng ibang unit yan. Diba? Ampere lang naman. Okay. So, force, lagay natin sa table. Ayan. Si force. In MKS, Newton. Kapag ka naman CGS, ano pag CGS? Dynes, and then kapag ka naman English, we have pound foot. Okay. So may conversion din yan eh. Ng Newton to dynes. Parang 1 Newton is equivalent to 10,000 dynes. Yan. Dagdag nyo na lang. Okay? Okay, so let's have an example. An armature conductor, 12 centimeters long, moves right angle to the magnetic flux density of 1.20 Tesla and carrying 5 amperes. What is the force experienced by the conductor? So we have here the final answer. So, first you have to analyze the problem. Ano, what are the given? So we have conductor of 12 centimeters long. So that is your length, 12 centimeters. Then it moves right angle. When we say right angle, what is the angle of that? Right angle. Hello. Yes po. Sige, magsalita na kayo para hindi ko na ito i-close.
90 po.
Okay, so we have 90 degrees. Then we have, thank you po pala. Then we have flux density of 1.20 Tesla. Then we have the current, which is 5 amperes. Okay. So, ang pinahanap ay force experienced by the conductor. So, tawag dito. From the given parameters, what can you say about the formula? What will we use? What will we use? Diba yan yung BIL sine theta? Pero ano doon? In MKS, CGS, or English?
CGS po ba?
MKS. Okay, so that's correct. So we have BIL sine theta. Okay. So, wag kayo magbe-base sa length. Ano? Mag-base kayo kay flux density. Okay, kung ano yung unit ni flux density, doon kayo mag-base kung anong gagamitin nyo or what to use formula. Okay? So, if the flux density is in terms of Tesla, it is in MKS. Because it is very easy to convert centimeters to meters, right? So, you have to convert it. You have to convert it first before substituting it to the formula. Okay, so we have here 1.20 Tesla. Then we have the current of 5 amperes. Then the length, which is 12 centimeters. So convert it into meters. We have 100 cm to 1 meter, right? So cancel, cancel. So 12 times 1 over 100. Then we have sine theta or sine 90 degrees. So please put it in your calculator and let's see if this is your final answer.
Sa kanya yung pinangalan yung unit na natin.
Ang oras na ba? 11:20. Okay. So, ano? What's your answer? Is it 0.72 Newton?
Magnet was put inside the coil of copper wire, a tiny electric current flows through the wire. Of course, by today's standards, Faraday's electric generator was
Hello? Diyan pa kayo?
pero because of that discovery,
May hawak ba kayong calcu?
Diyan na-develop at naging mataas na yung generation.
Okay, so 0.72 Newton.
Yan po yung mag-reduce.
Okay, so what if hinihingi sa inyo the force I in terms of dyes? Excuse me. What is the force experienced by the conductor in terms of dyes? Dyes. Ayan. So you have to convert it. So if you know the conversion, which is 1 Newton is equals to 10,000 dyes, so just convert it. So F is equals to 0.72 Newton times
Sa kanya pinangalan
1 Newton, 10,000 dyes. What will be your force? Hello? Yes, ano po yun?
Ma'am, hindi po ba 100,000 lines po yun?
100,000 ba? Ay, oo pala. 100,000. Kasi dapat ito ay maging 72,000 dyes. Okay. So, thank you for the correction. Lagyan natin dito. Kulang tayo ng 0. So, dapat po ang sagot dito ay 72,000 Newton. Dyes. Tama ba? Yan, okay na
Yes
yan?
po, ma'am.
Ayun. Okay, thank you po. Si ma'am ay kinakalawang na. Kinakalawang. So, ayun ha, pagka kayo ay may nakitang mali ang aking pen. Mali ang pen ko, so itatama ninyo. Nagkamali ang pen. Hindi yung sumula. Okay? So, yan. 72,000 dyes. Pero, if you don't know, ayan, if hindi kayo sure sa conversion, pwede nyo naman na idiretso sa formula. Di ba meron tayong formula in terms of dyes, which is F is equals to BIL sin theta over 10. Diba? Yung sagot mo dyan, naka-dyes na paglabas. Ano, hindi mo na kailangan convert. But you have to get the flux density in terms of what? In terms of what? Dapat ito. Dapat i-convert mo siya into ano nga po ang CGS ng flux density? Di ba, Gos? So, i-convert natin into gauss. So, ang conversion niya, 1 Tesla is equivalent to 10 raised to 4 gauss. Ayan. So, we will use here 1.20 Tesla times, naintindihan naman? So, 1 Tesla, 10 raised to 4 gauss. Okay, thank you. Then we have current of 5 amperes. Then, ang length natin, kung nasa CGS na tayo, hindi na natin papalitan. So, 12 na to. We will use 12 here. Then, sine 90 degrees. Divided by 10. Okay, let's see what will be the final answer. Is it 72,000 times? Tama po ba? 72,000?
Yes po, ma'am.
Opo, ma'am.
Okay, so, ayan ha, maalin doon. You can use the formulas for MKS, CGS, or English, whatever comes to your mind. Ano daw? Kung ano mas madali sa inyo, yun ang gamitin nyo. Okay? So, ayan. Next, ano pa ba? Sunod.
Next naman si Andre Marie Ampere. Sa kanya naman pinangalan ng
What time is it? 11:25. Kaya pa. Magnetomotive force or MM? F. So a force that sets up or tends to set up magnetic flux in a magnetic circuit by an electric current through a number of turns of a wire produces it. Okay, so, tawag dito. Ito yung may wire na nakapalibot. Ano, ang tawag dito, nakaloop. Okay. So, to get the magnetomotive force, we have the formula which is N times I. What is N? N is number of turns. And I is current in ampere. Current, ano? So that's why it's SI unit or MKS unit is ampere turn. Okay? So, hindi porket NI yan, ang gagawin nyo na ay turn ampere. No. Okay? It's ampere turn. Ampere turn, baliktad. So, kung nalilito kayo, edi ang gawin nyo, MMF is equals to in. Ayan. So that it's ampere turn. That's the SI unit or MKS unit of your magnetomotive force. Okay, again, you will use this only in MKS. Okay, so pasensya na. There are so many MKS, CGS, and English here. And magkakaiba talaga sila. Ano? And this is for CGS. Okay? So in CGS, you will use 0.4 pi and I, which is in Gilbert's. Okay, which is the CGS unit for magnetomotive force. Again, this is for number of turns. Number of turns pa rin yan. Of turns. And I is still current in ampere. Okay. So that is the magnetomotive force. Okay. Next, we have the magnetic field strength, magnetizing force, field strength, ano pa? Magnetic intensity. Tanggalin natin itong force na to, ha? Kasi yan ay dapat ay magnetizing force, itong nasa taas. Yan. So, yan ang tawag dyan, ha, kay H. We have magnetizing force, field strength, magnetic field strength, magnetic intensity, Okay. So, basta may strength at intensity and magnetizing force, yan po ay H. Okay. Diba yung beta, ano yun? Flux density. Then, yung phi ay flux or magnetizing flux or magnetic flux. Ito naman, basta may strength at intensity, H na agad yun. Okay? So it should be noted that the field strength is a vector quantity having both magnitude and direction. So MMF is the magnetomotive force per unit length of path of the magnetic flux, and it is also called the magnetizing force of the magnetic gradient. Okay, so sabi, si H daw or si field strength is makukuha using MMF over per unit length. So that will be MMF over L. Okay. Sulatin natin ng mas So H is equals to MMF over L or length. And then you can also use depende pala ito NI. So MMF over L, and you can also use this formula, which is flux density equal to mu H, where mu H is mu O mu R, mu O times mu R times H. Okay, so you can use that. You can use that. You can use that formula also. Babagalan natin ng imig para hindi magkamali. Tanggalin natin.
One form of energy.
Ang dami kasi nito nakasulat. Okay.
Meron tayo frictional energy. So, frictional energy, makakapag-produce tayo ng frictional electric.
Okay. So, ang ating magnetic field strength or field strength ay meron different units. Depende kung sa MKS, CGS, or English. So, ito yun. So, we have here field intensity. So, H we have in MKS, ampere turn per meter. CGS, we have Gilbert per centimeter, which is equivalent to Oersted. Oersted is like Oersted. Yan, ganyan po ha. Oersted ang tawag dyan. Ang basa dyan. Okay, pero sa English wala pala siya. This is ampere turn ha, AP. Ampere turn. Kung ampere turn yan, anong formula nito? N times I over L, di ba? So, NI over L. Ayan. So, to get the magnetic field strength, we have different formulas. It depends kung ano yung material. Okay, so if the material is a long straight wire, you will use H is equals to NI over 2 pi D. D is the distance in meter, N is the number of turns, I is the current in amperes, and length is in meters. Okay? Wala namang length dito eh. This is for long straight wire. But if the material is a long solenoid or simply solenoid, you will use NI over L, where N is the number of turns, I is the current in amperes, L is the length in meters. Okay? So in short, ito ay puro pang MKS. Okay, in MKS yan. Then we also have circular and square coil. If the material is circular coil, you will use NI over 2R. Okay. So N is the number of turns, I is current, then R is for radius. Okay, radius. Then in square coil, we have square root of 2 Ni over pi A. What is N? Number of turns. I is current in amperes, and A is the distance from the side. Yan, ang distance from the side. So, kalahati lang ha. From the center, papunta sa side, A yun. That is A. Let's have an example. Okay. So, a solenoid, 30 centimeters long, is wound with 300 turns. What is the value of its field strength inside the solenoid and when the coil is carrying a current of 2 amperes? So first, you have to analyze the problem and get all the given parameters. Get the given. We have the length, which is 30 centimeters. Excuse me. Then we have N, which is the number of turns, which is the 300 turns. What is the value of its field strength? What is field strength? H, diba? When the coil is carrying a current of 2 amperes. Current is 2 amperes. Sabi ay solenoid daw. If it is a solenoid, ano gagamitin? H is equals to what? What are we going to use? What formula?
Ni over L po.
Ni over L. That's correct. Ni over L. Okay. Kasi sabi ay solenoid. Ano? And then, ito dapat lahat ay every parameter should be in terms of MKS unit. MKS unit. So, we will convert. Ano? N is simply 300 turns. Current is 2 amperes. Then L or length is 30 centimeters. Times, it should be in meters, right? So we have to convert it. So 100 centimeters into 1 meter. Cancel cm, cancel cm. So I want to see the conversion in your computation and solution. Okay? I need to see how you convert it. Ano? I don't want you to use shortcut and something like that. Ano? You have to show me how you did the conversion and also complete solution always. Ha? Tatandaan nyo yun. So what's the answer? $2,000 ampere turn per meter. Yung iba, ganito ba yung nakuha? Tama ba yun?
Yes po, ma'am.
Ayan. So, this is the final answer. Okay, another one. Oh my God. Sorry po ha. For the sick talaga ang person din. Hirap. Nangangatin na lang namin to. Okay, last example. Okay, so if a current of 5 amperes flows through a long wire. Wait lang. Okay, pasensya na ka. Ang hirap talaga ng may ubo. Tapos imik ka ng imik. Nakakapangat na lalamunan. Okay, so if current of 5 amperes flows through a long wire of radius 0.04 meter, what is the intensity of the magnetic field produced 0.02 meter away from the surface of the wire? Okay. Anong sabi? Long wire. Anong formula ng long wire? Long straight wire yata yun. H is equals to Ni over ano? 2
2 pi r po.
2 pi. No, it's 2 pi d, ha? Saan na yun? Ayan, ha? 2 pi d po yan. Distance. Hindi siya r, which is radius. Pakipaltan po ako. That is 2 pi d. Distance. Okay? So, ang r ay for circular coil only. Ha? Para hindi kayo malito. Mali kasi yung nakasulat dito nung una eh. R is for radius only in circular coil. Okay? Ayan. So, we have Ni 2 pi d for distance. Okay? That is for long wire. Okay. So, if the problem doesn't say circular coil and it gives you radius, you don't have to use it. Okay? Pampalito lang yun. Okay? If it's a long wire, you only need the distance, not the radius. So, itong radius na ito, which is 0.04 is nothing. Ano? Binigay lang nila para pampalito. Okay? So, ito yung kanyang computation. Ayan. So, we have Ni 2 pi d. So, N is for number of turn. Then, I is for the current. Then, D is the distance. So, R is, you will not use this at all because this is not a circular coil. If the problem says circular coil, then you will use it. Then, you will not use the distance naman. Ano, only the radius. Okay, and then, if the number of turns is not given, you will use 1. Ano, just use 1. If N is not given, matic, use 1. Okay, if N is not given, use 1 turn. Okay, so we have 1 times 5 amperes divided by 2 pi times distance of 0.02. The answer will be equal to 39.7887 ampere turn per meter. Okay, do you understand? Hello?
Yes po, ma'am.
Okay. So, ayan. Anong oras na? 11:41. O, last na problem. Last problem na to, ha? Then, continuation na lang tayo sa Friday. So, a flat circular coil with 40 loops of wire has a diameter of 32 centimeter. What current must flow in its wire so it will produce a field of 3 times 10 raised to negative 4 Weber per m squared? So, first is analyze the given. So, analyze the problem and get the given parameter. So, we have circular coil daw. What is the formula in getting anong tawag dito? Ano bang given? Basta circular coil. Later na lang. So, with 40 loops, ibig sabihin that is your N. 40 loops. Diameter of 32 centimeters. What current? So, current is the missing parameter. And we have the field. So, that is, ano daw to? Dahil Weber per m squared, ano yan? Weber per m squared, ano yan? Di ba ano yan? Flux density? So, 3.0 times 10 raised to negative 4. So, mag-unit analysis kayo ha para malaman nyo kung ano yung given. Weber per m squared. Kasi nakalagay dito, field of ano lang. Field lang. Anong field yun? Okay, so that is flux density. Ano? Tingnan niyo po. Nalipat ba? Yan. Ayan, oh, Weber per m squared. Okay. So, ayan. Weber per m squared. Ngayon, sa circular coil, ito, H is equals to Ni over 2R. Ano? So, H ngayon, wala tayong H. Saan tayo kukuha? Meron tayong flux density. Wala naman tayong field intensity. So, ano gagawin natin? Di ba may formula tayo na beta is equals to mu H. Tama? Or beta is equals to mu O, mu RH. Okay, so kuhanin natin yung equivalent ni H. So, kung ganun, iwanan natin to dito sa right side. Ilipat natin pababa itong dalawa so that it will be H is equals to beta over mu O, mu R is equals to H, diba? So, ito na yung ilagay natin dito. Ano? So, this one will be beta over mu O, mu R is equals to Ni over 2R. So, ano yung missing parameter natin, Karen? Okay? Meron tayong B, meron tayong N, meron tayong radius galing dito sa diameter. Ha? Then, mu O natin. Ano yung magiging mu O natin? Mu O is constant. Kasi MKS to eh. Naka-MKS. MKS, so mu O is constant, 33, right? So, lagay natin ha. So, 3 times 10 raised to negative 4 over constant 33 times, anong mu R natin? Mu R walang given, di ba? So, you will use 1 equals, anong ating loop or turns? So, we have 40. Then, current is the missing one. 2 times R. Anong R natin? 32. Ano bang R natin? R is 16 centimeters. So, i-convert natin siya into meters kasi naka-MKS tayo. So, this one will be 16 centimeters times 1 meter, 100 centimeters. Cancel, cancel. Okay, so isa-isahin natin, ha? Huwag kayong mag-shift solve. Okay? Huwag mag-shift solve. Okay, ano gagawin? Eh, di mag-cross multiply kayo. So, this one will be 0.16, tama? So, 2 times 0.16, that will be 0.32, di ba? I-cross multiply nyo, itaas nyo dito. Tapos, itong 40, ibaba nyo dito. I-multiply nyo dito kay constant 33 at 1. Maiiwan si I dito sa right side kasi siya yung unknown. Okay? So, ano magiging equation natin? 3 times 10 raised to negative 4 times 2 times 0.16 over constant 33 times 1 times 40 equals I. Ayan. Constant 33, shift 7, tapos lagay nyo ay 33 equal. So, yun, ang lalabas dun ay mu O. So, pakicheck ako kung ang naging sagot ay 1.9099. Meron naman akong calculator dito. I-calculate nga pala ako dito. Ayan. So, let's see. Nakikita niyo ba yung calcu ko na very cute? Ayan. Okay, so we have 3 times 10 raised to negative 4 times 2 times 0.16 over Constant 33. Shift 7, 33. Ayan. UO, di ba? Then, 1. Huwag na natin ilagay si 1. Then, we have 40 equals. So, we have 1.909859317. So, you only have to get to 4 decimal places. So, that will be 1.9099. Ano? That is your final answer. Okay, understand? You understand?
Yes po, ma'am.
Okay, so that is for your example number 3. Then, magnetic forces will be on Friday. May Friday. Wala palang pasok ng Friday. Ano? So, ihahabol na lang natin next week, ha? Wala nga palang pasok ng Friday. Friday ako ng Friday. Okay, so ayan. Any question? So tayo ay nasa slide 29 na ha. Tatandaan ninyo. Slide 29. So do you have any questions?
Wala naman po, ma'am.
Okay, so if there's none, you may now